Hello, traveler. I've been lost in this dungeon for nigh 2 weeks. I don't even know if I've been in this room before. If only there was a way I could efficiently store a large map in my meager pack. But there is. The Redis Bitmap will show us the way. Follow me to learn more.
You might remember that Redis strings allow you to store binary data. What's really cool is that Redis provides a set of commands that allow you to treat these binary strings as bitmaps. This means that you can set and get any bit in the string, and you can do it with constant time complexity, which is as efficient as it gets. To demonstrate the power of Redis Bitmaps, we'll be implementing an overworld mapping system to keep track of the path of a character in the online role-playing game Mages and Minotaurs. When players start out on a new level, the map will be dark, as they won't have traveled in any direction. As players explore, they'll be able to see their path on the map, and they'll also see what percentage of the map they've explored. We'll learn how to track the movement of a player across our game map. We'll also learn how to retrieve the player's path for future gaming sessions. Lastly, we'll learn how to check how many map tiles have been explored. Think of a Redis bitmap as an array of bits stored in a string. We'll associate each game map tile on its XY coordinate plane with an offset in the bitmap. A 1 bit and an offset indicates that a player has visited the corresponding tile. All other bits will default to 0, meaning unvisited. Our first map will be a 20 by 20 coordinate plane with the origin at 0, 0 on the bottom left. We'll need a formula to compute the offset based on the desired XY coordinate. Let's use this formula: y multiplied by the width of the map plus x. With the coordinates 16, 12, we see that the offset will be 256. To set an individual bit, we'll use the SETBIT command. SETBIT takes 3 arguments: the key, which is the name of our bitmap, the bit offset, which is the bit offset from the beginning of the bitmap, and the value for that bit, which will be 1 or 0. Let's start our player around the center of the bottom of the dungeon map at coordinate 9, 0. Since we're tracking a specific player's path for this particular map, we'll name the bitmap player:42:map:3, with 42 being the player's ID and 3 being the ID of the dungeon map. The full command will be setbit ourKey 91. This initial setBit command creates the bitmap and sets the 9th bit to 1. All bits from 0 through 8 are initialized to 0. Let's imagine our player moves up or north. 1 tile north will place our player at the coordinate 9, 1, which resolves to offset 29. The next command will be setbit ourKey 29, 1. If we were to see a binary string representation of our bitmap, it wouldn't make a lot of sense. But if we stack the string 20 characters wide on top of itself, we'll soon see a pattern. Watch this string evolve as we set more and more bits. Do you see a path? This is how we store all of the tiles our player has visited in a bitmap. To get values from our bitmap, we use the GETBIT command, providing the key and the offset. Let's check a couple of map locations to see how this works. If we run the command getBit ourKey 71, 1 will be returned. This means our player has visited the tile before. If we run the command getBit ourKey 342, 0 will be returned. This means our player has not yet visited this tile. To show the percentage of explored map tiles to the user, we'll use the BITCOUNT command. The command BITCOUNT and our key returns the number of 1 bits in the player's dungeon bitmap. If we divide that number by the total number of tiles in our map, we'll get the percentage of tiles that player has visited. Okay, let's review. We just learned how to represent our game player's path in an extremely space-efficient manner. We learned how to create a Redis bitmap and store a bit at an offset with setBit. We retrieved data stored at an offset with the getBit command. Finally, we used BitCount to determine how much of the map a player has explored. What else can we do with bit-level operations in Redis? In this video, we've only just scratched the surface. We limited ourselves to getting and setting individual bits, but Redis actually supports variable length bit fields using all of the standard bitwise operations. Think AND, OR, exclusive OR, and so on. We'll look at this in another video, but if you're itching for more now, check out the bit field command. To learn more about Redis bitmaps, sign up for our free online course, Introduction to Redis Data Structures. It's part of Redis University, our online learning platform for all things Redis.
Thank you for navigating the twists and turns of the Redis Bitmaps with me. I bid you farewell, traveler, and hope to bump into you again. And always keep your map at the ready. Yeah.